Good morning, student. In today's class, we will discuss sampling distributions and sampling designs. So, first of all, before discussing what is sampling distributions, the first question arises, what is a distribution? You have heard about the frequency distribution in which we make a tabular arrangement of variable values along with their frequencies. Similarly, exactly in similar manner, you can create a uh, probability distribution. Means if you are able to find out the probability of various event of a random experiment and enlist them in a tabular form, then it becomes the probability distribution. So, before going in detail about what is the probability distribution, first question arises, what is the random experiment or the outcome of an experiment is random. We are not able to find out in advance what value will come. For example, if you toss a coin, then we cannot know how इन एडवांस द हेड विल कम और द टेल विल कम. हम पहले नहीं बता सकते जब तक वो इवेंट अकर ना हो जाए. जब आपने टॉस को क्वाइन किया तो एडवांस में हमें ये पता नहीं है कि हेड आएगा या टेल आएगा. इसीलिए इसको हम रैंडम एक्सपेरिमेंट बोलते हैं और उसका जो आउटकम है वो भी रैंडम है, हमें एडवांस में नहीं पता. सो फर्स्ट ऑफ ऑल वी विल डिस्कस what is the random variables. So random variable is nothing. A variable you should know whose value change is known as a variable. A variable whose values depend on the outcome of an experiment is called random variable. Since we are talking about the probability, that's why a random variable is a variable whose value depend on the result of an experiment. Or when we talk about the random variable in mathematical term, then you can define it like it is a real valued function. It is a real valued function that maps the sample space. Sample space is all possible outcome of an experiment to the real line. Clear? Now, on the basis of the nature of the random variable, we can categorize the random variable in two categories. First one is the discrete random variable and second one is the continuous random variable. So, discrete random variable क्या होता है? A variable which takes different values like say 0, 1, 2, 3, 4, 5, whole number type values. And example, for example, if you are interested in to find out the number of printing mistake in a page, then printing mistake is always come out say one mistake, two mistake, three mistake, or no mistake, or five mistakes. The mistake you cannot find 2.3 mistake. So this is a discrete type of outcome you will get. Or another example, here is the phone calls received by an operator. He or she may receive the call like one call, two call, three call, four call. 1.5 call you will never get. So there are distinct values like 0, 1, 2. So such type of variables which take such type of values are called discrete random variable. Because why these random? Because you are getting the values from a random experiment. Second one is the continuous random variable. A random variable which take all possible value in a range. For example, rainfall on a day. Suppose rainfall, you can say it is 5 centimeter to 20 centimeter. So between 5 and 20, there is infinite number of values, such as 5.1, 5.11, 5.12, and so on and so forth. So there is infinite number of values. Similarly, if you talking about the height of the student between a range, say 160 centimeter to 170 centimeter, again we will get infinite number of values. Similarly, like weight means you get the real values. Now, on the basis of these two types of variable, we define the probability distribution. जैसा मैंने पहले बताया, probability distribution कुछ नहीं है, it is exactly similar to frequency distribution. Frequency distribution में हम क्या करते थे? We will take the value of x and we will take their frequency. How many time a variable or value of x repeated. For example, 0 repeated 5 times, so 0, and we put 5 against this 0 and make a table. So this becomes the frequency distribution. On the similar line, you can create the probability distribution. If you make a tabular arrangement of a variate value along with their probability in a tabular form, then it becomes a probability distribution. So probability distribution is a function that assigns probability to different possible values of a random variable. Or in simple term, the possible values of a variable can take their associated probability, and we call it as a probability distribution. Let us explain it clearly with the help of an example. Suppose a farmer or a scientist uh, plant three seeds, and the random variable he or she defines as the number of seeds that germinates. So suppose we plant three seeds and we define a random variable, say x, as the number of seeds germinates. Then the possible values of x, out of three seed, no seed will be germinated. One possibility. One seed germinate, two seed germinate, and three seed germinate, because we have all three seeds. And if we are able to find out their probability, suppose this is x, if we are able to find out the probability of x, means no seed germinate, what is its probability? One seed germinate, what is its probability? Two seed germinate, उसकी क्या probability होगी? Three क्या होगी? And make a table in which one column contains the variate value and other column contains the probability of happening that value. Then this tabular arrangement is known as probability distribution. Clear? So if x is equal to 0 means no seed will germinate. X is equal to 1 means one seed germinate. X is equal to 2 means two germinate and three germinate. Now let us say the probability of each seed germination is given to us. What is the probability that x is equal to 0.7, and probability of x bar means probability of not germinating a seed is 1 minus 0.7, so it is 0.3. If it is given, then you can find These probability using a binomial formula which calculate the probability of each x using a mathematical relation, a mathematical function which is given as probability that x is equal to k is given by nck p raised to power k 1 minus p raised to power n minus k. Now, what are these nck? N is the total number of seeds. K is the number of seed we want to, whether they are germinating or not. In this case, we have three possibility. NC0 means no seed is germinating. NC, N is 3, so I put here 3. 3C1, one seed germinating. 3C2 means two seed germinating. We are interested in to find out the probability that two seed will germinate. 3C3 means three seeds are germinating. So I think you are clear with this term. Then P. P is the probability, this probability of germination. It is 0.7. K. K means if you are interested in 0 seed germination, then K will be 0. 1 germination, K will be 1. 2 germination, K will be 2. 3 germination, K will be 3. And 1 minus P, it is I have already calculated 0.3. एंड एन माइनस के एन इज द टोटल सीड एंड के जो आप निकाल रहे हो जीरो है तो एन माइनस जीरो हो जाएगा 3 - 0 3 - 1 3 - 2 3 - 3 and so on so forth. So you can say this is called the probability distribution function because with the help of this function we are able to find out various probability of seed germination. That's why it is called probability distribution function, a function which create the probability distribution. Here n is the number of trial. In our case, it is 3. K is the number of successes. In our case, the seed germination. P is the probability of success. Success we are considering the seed will be germinated or not. So this is a formula up to now. Now this formula is known as the binomial distribution. How? What is its property? Under what situation we will use this formula to calculate the probability? Let us see in next slide. So binomial distribution. First of all, we will define what is binomial distribution. So binomial distribution is nothing. It is a way to calculate probability or it is a formula which calculates the probability of getting certain number of successes in fixed number of trial. So the binomial distribution is way to calculate the probability of getting certain number of successes which is represented by P in a fixed number of trial which is represented by N. And when P is the probability of success, of course 1 minus P will be the probability of failure. Right? So each trial has two outcomes, either success or failure. Tossing a coin, either head will come or tail will come. So in binomial distribution, each trial has only two possible outcomes, success whose probability is P and failure whose probability is 1 minus P. And if you take an example of planting the seeds, a success could be seed will germinate and failure could mean it does not germinate. Then this type of probability, if you are interested in, is called as a distribution, probability distribution, which is known as a binomial. So this distribution is called binomial because it is based on repeated Bernoulli's trial. Now Bernoulli's trial क्या है? A trial, or you can say an independent trials whose only two outcome, tossing a coin, head will come, tail will come, success or failure, smoker and non-smoker, male or female. Means if you are picking a boy at random, it, it may be male or it may be female. Like, and the total number of successes in all trials follows the binomial distribution. Means if you want to find, suppose a Bernoulli trial is performed n number of times and you are interested in exactly k successes, then getting k successes out of these n trial, it will follow the binomial distribution. So the probability of getting exactly k successes in n trial is given by a formula which is known as binomial distribution function. Probability that random variable x has exactly k successes is given by nck p raised to power k 1 minus p raised to power n minus k, where I have already explained n is the total number of trials and k is the number of successes out of n trials, and p is the probability of successes in one trial, and 1 minus p is probability of failure in one trial, and this term I have already explained, nck is given by n factorial divided by k factorial into n minus k factorial. Now first of all, what is factorial? Factorial, n factorial means it is a continuous product of first n numbers like n. And k factorial means it is a product of k numbers. So n minus k factorial means you subtract k from n, whatever you get, it is the product of these numbers. So nck is known as binomial coefficient. This is known as binomial coefficient, and which calculates the number of ways to arrange k successes in n trial. For example, if your number of trial is 3 and you want to find out 2 successes. So 3c2 will be 3 factorial over 2 factorial into 3 minus 2 factorial. 3 factorial is a continuous product of three numbers 1 to 3, so it is 6, 2 factorial 2, and 1 factorial is 1. So you can get the number of ways in three possible ways, the number of successes. I think it is clear. Now, this distribution has certain properties, or you can say certain assumptions, on which you can apply the formula of this distribution for getting the number of successes in n trial. आप n ट्रायल में से कितनी सक्सेसेस आपकी हैं उनकी प्रोबेबिलिटी निकाल सकते हो, बट you should be clear on few assumptions. Now let us talk about assumptions or property of the binomial distribution. So what are the properties of the binomial distribution? First property जो binomial distribution की है, the fixed number of trials. You should know in advance how many trials are there, total number of trials are there. So first is fixed number of trials. The total number of trials which is given by n is decided in advance. This is first assumption. Number two, the result of each trial does not affect the result of another. एक ट्रायल का रिजल्ट दूसरे ट्रायल को अफेक्ट नहीं करेगा. It means the trials are independent. So independent trials, the result of one trial does not affect the result of another trial. Number three, because you are discussing the properties of binomial distribution, which I have already said that it is based on Bernoulli's trial. So in Bernoulli's trial, we have only two outcomes. So each trial has two possible outcomes, either success or failure. So third important property is only two outcomes should be there. And fourth one, which is very important, is constant probability. The probability of success, which is represented by P, remains same for every trial. Right? So let us understand this distribution with the help of an example. Again, I am considering the same example of seed germination. Suppose a scientist plants three seeds. एक साइंटिस्ट ने तीन सीड जमीन में डाले. The probability of seed germinating is 70%. It means a seed will germinate or not. There is a 70% chance that seed will germinate. So this is the probability of success. So P will be 0.7. And probability of failure means seed will not germinate is 1 minus 0.7. So it is 0.3. So it is 1 minus P. And it is also represented by Q also. And it is also represented by P bar. ये कहीं किसी बुक में कोई भी नोटेशन हो सकता है. Now we want to calculate the probability of exactly 0 seed germinate, 1 seed germinate, 2 seed germinate, or 3 seed germinate. So what we do is, we will use, since only two outcomes are there, third property is fulfilled, and number of trials means we are in advance testing three seeds, so fixed number of trial property is fulfilled. And independent trials means the germination of one seed, single seed, will not affect the germination of other. That's why the trials are independent. And it is given that there is a 70% chance of germinating a seed. एक सीड के जर्मिनेट होने के 70% चांस है, वो हमें बता दिया गया. तो द एंड इट रिमेन सेम फॉर ऑल थ्री सीड्स. So it has constant probability. So all the four essential condition of binomial distributions are fulfilled. Now using the binomial formula, binomial probability distribution function, we can calculate the probability of exactly 0 seed, 1 seed, 2 seed and 3 seed. For that, what I do is I make a table. Suppose X is my variable which represents the number of seed germinated. Then in second column, certain computation we will do, and in final column we will put the probability. So suppose we are interested in finding out the probability of that no seed will germinate or 0 seed germinate, means no seed will germinate. So value of X will be 0. So this is my first possibility. And using binomial distribution, which is given by NCK, P raised to power K, 1 minus P raised to power N minus K. Here N is the number of seed, so it is 3. K has taken value X is equal to K, because in definition probability of X is equal to K. So K takes 0 value, so 3C0. P raised to power K, it is 0. And 1 minus P, which is 0.3 raised to power N minus K. N is 3 minus K is 0. When you simplify this, you will get 0.027. Right? Similarly, you can find out the probability that one seed will germinate. Here K will be 1. So formula becomes N, that is 3, C, K, that is 1, 0.7 raised to power K, 1, 1 minus 0.7, that is 0.3 raised to power N minus K. N is 3, K is 1, so it is 2. And it comes out to be equal to 0.189. Similarly, for 2, and you can calculate the probability for 3 seed will germinate is this one. Now, this is a tabular arrangement. You compute all the probability corresponding to the variate value x, which takes value 0, 1, 2, and 3. And these are their respective probability. Now, tabular arrangement, is known as probability distribution. Now, from this probability distribution, what you will get, what interpretation you can infer, क्या आप इससे क्या रिजल्ट निकाल सकते हो? इस टेबल में अगर हम देखेंगे तो मैक्सिमम प्रोबेबिलिटी यहाँ पे है। इसका मतलब क्या है कि द मैक्सिमम चांस ऑफ जर्मिनेटिंग टू सीड विल बी देयर इन दिस एक्सपेरिमेंट। मिनिमम प्रोबेबिलिटी यहाँ पे है। इट मीन्स देयर इज मिनिमम चांस ऑफ गेटिंग of germinating no seed. So you can interpret the result like this. The most likely outcome is two seeds germinating because it has maximum probability. Second is there is 34.3% chance that all the three seed will germinate. And the probability of no seed germinating is very low. This is 2.7%. So with the help of probability distribution, you can see the most likely event and you can see the, say, no likely event, less likely event. Or if all event will happen, what will be the probability? Means you can interpret result according to your view. Similar to this binomial distribution, there is another this binomial distribution is also known as discrete distribution because the random variable x takes discrete values. It, it is not taking the continuous value. That's why it is called discrete distribution. There is one more important discrete distribution we have, which is known as Poisson distribution. So what is Poisson distribution? The Poisson distribution generally used to calculate the probability of event which is happening in a certain number of time in fixed interval or space. जैसे for example, the number of road accident between 6 a.m. to 6 p.m. ये बहुत ज़्यादा नहीं होते, ये फिक्स थोड़े होते हैं, काउंटेबल नंबर ऑफ होते हैं. So under such and the probability of success remain constant, right, under that interval, and the number of events is infinitely say large. So under such situation, the Poisson distribution, the probability of happening an event will follow a Poisson distribution. We will explain it in this slide. So first of all, definition, the Poisson distribution is used to calculate the probability of an event which is happening a certain number of times in a fixed interval of time or space. Of course, this distribution has certain assumptions like binomial distribution. जिस तरह binomial distribution की assumption थी ना चार, the number of trials should be fixed in advance, probability of an event remain constant from trial to trial, trials are independent. Likewise, we have certain assumptions of Poisson distribution. It assumes that again the event should be independent of each other, right? Number two, the average rate of occurrences lambda is constant. It should not be changed. If you talk about an example, it can be used to predict the number of pests on a plant, the number of customer arriving at a store in a particular interval of time, the number of calls received at a call center in a span of time. And mathematically, you can find the probability of observing exactly k events is probability of x is equal to k e raised to power minus lambda, lambda raised to power k divided by k factorial. Now, where the x is the number of events, number of accidents, you can say, number of deaths, you can say, number of calls, you can say, number of customer, right? And lambda is the number of events per interval कि किस रेट से इवेंट अक्कर हो रहे हैं, that is the average number of event per interval. And E is known as Euler's number, whose value is given by 2.718. And of course, k factorial is the factorial of k. Now, with the help of example, you will be able to understand the Poisson distribution more clearly. ठीक है, तो अब let us move towards example. So example is a farmer observes that average number of pests per plant is 4. उसने ये ऑब्जर्व किया कि there are 4 pests per plant. So this is our lambda. Now the probability of finding 0 pests, 1 pest, 2 pests up to 8 pests, they follow the Poisson distribution because lambda remain constant. It is given. Then how you can create the Poisson distribution? So again, consider a table in which x represent the number of pests. Then we have computations and then we find out the probability. So x is equal to 0. It means no pests present on the plant will be calculated e raised to power minus 4. This is lambda. Lambda raised to power 0, the value of k, or k factorial. 0 factorial, and 0 factorial is always equal to 1. So it comes out to be equal to this. Similarly, 2, you will get this 1, 2, 3, 4, 5, 6, 7, and 8. Now from this table, you can find out the interpretation. Means we are seeing here that these two event has maximum probability. कहने का मतलब क्या हुआ कि प्लांट पे 3 और 4 पेस्ट रहने की प्रोबेबिलिटी सबसे ज्यादा है, राइट? और जैसे जैसे नंबर ऑफ पेस्ट इंक्रीज हो रहे हैं, द प्रोबेबिलिटी ऑफ देयर प्रेजेंट ऑन द प्लांट विल डिक्रीजिंग. जैसे 3 पे थी, 4 पे थी, 5 पे कम होगी, 6 पे कम होगी, 7 पे कम होगी, 8 पे कम होगी, राइट? सो लाइकवाइज यू कैन इंटरप्रेट अकॉर्डिंगली. So the most likely number of pests is 4 because it has maximum probability. The probability decreases as the number of pests increases. जैसे जैसे pests बढ़ रहे हैं, probability decrease हो रही है. And there is a very small chance, 1.83% of having no pests. So with the help of this probability distribution, you can interpret many things. Now we will move towards another distribution which is known as normal distribution. Again, this is again of discrete type distribution. Discrete random variable का distribution है. अब हम एक डिस्ट्रीब्यूशन जो कि बहुत इंपॉर्टेंट है स्टैटिस्टिक्स में, मतलब ऑलमोस्ट हर मेथड में उसकी एप्लीकेशन है, which is known as normal distribution, which is of continuous nature. So we will talk about the normal distribution. What is normal distribution? Define. So the normal distribution, which is discovered by Gauss in 1809, is a continuous probability distribution that describes how values are distributed symmetrically around the mean value, say mu, and it is represented by a bell-shaped curve like this, and mean lies here. So it is a symmetrical. अगर इस हम कर्व को फोल्ड करें तो एक दूसरे की ये मिरर इमेज होंगी, where the most values are close to this mean. ज्यादातर वैल्यू यहीं पे क्लस्टर होंगी, ठीक है. The probability decreases as the value move further from. जैसे जैसे हम इधर घूमेंगे पॉजिटिव साइड में या इधर जाएंगे नेगेटिव साइड में तो प्रोबेबिलिटी कम होती जाएगी, जैसा कि ग्राफ से आपको नजर आ रहा है. एंड mathematically, how you can compute such kind of probability? You can use the mathematical formula, the probability density function of a continuous random variable which follow the normal distribution is given by f of x. It is equal to 1 by sigma under root 2 pi e raised to power x minus mu over 2 sigma square. Now there are many things. X is the value of the variable, random variable which is of continuous, and mu is the mean, sigma square is the variance, and E is the Euler constant. Now another question arises, what this x can take, what value this x can take, x क्या क्या value ले सकता है. So x can take any value between minus infinity to plus infinity. Similarly, your mean can take, since x can take any value, so mean can also take any value from minus infinity to plus infinity. And sigma is always greater than 0, being the variance. So x is the value of the random variable, which is of continuous nature. Mu is the mean, means this is the center of your distribution. Sigma is the standard deviation, which is known as spread of the distribution, कि आपका डाटा मीन के चारों तरफ कितना फैला हुआ है. And E is Euler's constant, whose value is 2.718. I have already explained. Pi is again a constant having value 3.1416. Right? So this is the definition of normal distribution. अब हमारे साथ प्रॉब्लम क्या है कि when we are taking x, so it can take minus infinity to plus infinity, and the value of when value of x is large, then computation of fx becomes very difficult. For that, we will reduce the scale, change of the origin and change of the scale. हम एक ऐसा वेरिएबल डिफाइन करेंगे जिससे हमारी कंप्यूटेशन आसान हो जाए, उसको हम बोलते हैं स्टैंडर्ड नॉर्मल वेरिएट. हम क्या करेंगे इन दैट केस, वी विल सब्सट्रैक्ट म्यू from the value of x and divide it by sigma. If such kind of transformation is made on this x variable, then the new variable which is represented by z is known as standard normal variate. अब इस स्टैंडर्ड नॉर्मल वेरिएट से हम नया डिस्ट्रीब्यूशन निकालेंगे. वो डिस्ट्रीब्यूशन हमारे पास इस तरह की एक कर्व देगा जिसके अंदर जिसकी टेबुलेटेड वैल्यू हमारे पास अवेलेबल है, एंड वी कैन फाइंड द प्रोबेबिलिटी ऑफ any values of x, right? So let us start with the properties of the normal distribution. So first property is standard normal variate. If random variable x has mean mu and variance sigma square, then if we define a new variable z which is x minus mu over sigma, this variable is called standard normal variate. And if you find the distribution of this variate, it has zero mean and variance equal to 1. And its probability density function is generally represented by phi of z, which is given by 1 by root 2 pi e raised to power minus z square by 2. So it seems quite simple as compared to previous one. Now, what this z can take value? It can take anywhere between minus infinity to infinity. Now, when we plot this distribution, so you will get a bell-shaped curve. Here mu will be 0 and you will get a bell-shaped curve, right? Now, we will define this uh, standard normal variate. तो पहली प्रॉपर्टी क्या है? The curve is bell-shaped, एक घंटी की तरह होगी, and it is symmetrical about x is equal to mu. ठीक है, ये सिमेट्रिकल होगी. जब इस कर्व को हम फोल्ड करेंगे तो ये लाइन इस लाइन के ऊपर एग्जैक्टली आ जाएगी. दिस साइड लाइन विल एग्जैक्टली कवर दिस लाइन. नंबर सेकंड प्रॉपर्टी, द मीन, मीडियन एंड मोड ऑफ दिस स्टैंडर्ड नॉर्मल वेरिएट विल बी सेम. सो मीन यहाँ पे मोड भी यहीं पे होगा और मीडियन भी यहीं पे होगा, राइट. Then the curve extends infinitely on both sides and never touches the. तो ये कर्व आपकी infinitely चलेगी but it cannot touch the x axis. चलती जाएगी लेकिन x axis को touch नहीं करेगी, right, on the horizontal line. Then the areas under the curve. See, so this is a bell-shaped curve and you will see here this is the mean and this line represent mu minus sigma and this line represent mu plus sigma. This line represent mu plus 2 sigma and this line represent mu minus 2 sigma. This is 3 sigma and so on and so forth. So if we talk about the area under mu minus sigma, I mean to say under this and under this. If you talk about this area under the curve, so this is 68.26% mu plus minus 1 sigma. Similarly, up to here, if we consider this area, mu plus minus 2 sigma, then it covers 95.44% of the total area. And we are assuming that total area under curve is 1.0. Similarly, if you talk about mu plus minus 3 sigma, then this area is 99.7% and total area under the curve is 1. Now, using these properties and table which is already available, you can find the area under curve of various values of z. The sum of difference of, now another important property, suppose x1 is distributed normal with mean mu1 and variance sigma 1 square. X2 is again a normal variable with mean mu2 and variance sigma 2 square. Then if we want to find out the distribution of their sum, distribution of their difference, so suppose this is S, this is D, then the S will also distributed normal. Similarly, D will also distributed normal, I mean to say. And the point of inflection are x is equal to mu plus minus sigma and all odd ordered moment about mean are 0, right? So these are the few most important probability distribution. So since we are discussing sampling design and sampling distribution in subsequent lectures, so before going to sampling design and sampling distribution, it is very much important to understand what is probability distribution. And these are three major probability distribution which you should keep in mind when you talk about the subsequent lectures. तो आपको ये आना बहुत ज़रूरी है कि प्रोबेबिलिटी डिस्ट्रीब्यूशन क्या है, रैंडम वेरिएबल क्या है, डिस्क्रीट रैंडम वेरिएबल क्या है, कंटिन्यूस रैंडम वेरिएबल क्या है, डिस्क्रीट प्रोबेबिलिटी डिस्ट्रीब्यूशन कौन कौन से हैं, बाइनोमियल हो गया, पॉइसन हो गया, कंटिन्यूस प्रोबेबिलिटी डिस्ट्रीब्यूशन आपका नॉर्मल हो गया। तो आपको इसको थोड़ा सा समराइज करेंगे एंड देन वी विल talk about in next lecture sampling design and sampling distribution. So thank you very much for your patience.